Every rule that keeps a modern airliner or a rocket from killing everyone on board was written by something going catastrophically wrong first. 7 disasters did more to reshape aerospace engineering than any safety committee ever has. And the last one didn't just cause a crash. It invented the entire science of figuring out why aircraft fail in the first place. We're counting down by consequence, not by body count. Number 7 is a runway collision in the Canary Islands in 1977, and it's the reason every pilot on Earth now reads back their clearance word for word, every single time. 2 Boeing 707s tried to use the same foggy runway at the same time. The KLM captain, under pressure to beat a duty time deadline, began his takeoff roll without a clearance he was certain he'd been given. 583 people died, still the deadliest accident in aviation history, and it traced back to one ambiguous radio call. Standardized phraseology and mandatory readbacks came directly out of that runway. Number 6 happened when 18 feet of an airliner's roof peeled away at 24,000 feet, and the plane kept flying anyway. Aloha Airlines Flight 243 had flown nearly 90,000 short island hops, and salt air corrosion had been quietly weakening the glue between fuselage skin panels for years. In 1988, the roof tore off mid-flight over Hawaii, sweeping out a flight attendant, but the pilots landed it with half the cabin open to the sky. The industry answered with the aging aircraft inspection program every high-cycle airliner still follows, built specifically to catch corrosion nobody could see from outside. Number 5 is the one that made an almost empty fuel tank more dangerous than a full one, which is the opposite of what most people would guess. TWA Flight 800 exploded off Long Island in 1996 when vapor in a nearly empty center fuel tank ignited, likely from a spark in aging wiring. All 230 people aboard were killed, and early witness reports of a streak in the sky sent investigators chasing a missile theory for months before the wiring was confirmed. Every airliner built since has carried a fuel tank inerting system, pumping in inert gas so that vapor can never ignite again. Number 4 is the crash that turned lightning from an act of God into an engineering problem the industry actually had to solve. Pan American Flight 214 was struck by lightning over Maryland in 1963, and the bolt ignited vapor inside a wing fuel tank. The aircraft was destroyed in midair, and the entire fleet of that model was briefly grounded while investigators worked out how a strike that planes survive constantly had managed to kill this one. Fuel tank lightning protection, bonding, and static wicks across the entire industry trace back to that single strike. Number 3 is the one everyone already knows, but almost nobody knows it was a decision made the night before, not a random failure. Engineers on the Challenger program had warned that the rubber O-ring sealing its solid rocket boosters went stiff in cold weather and might not seal properly. Management launched anyway on a freezing January morning in 1986, and a seal failed 73 seconds after liftoff, breaking the shuttle apart on live television. During the public inquiry, physicist Richard Feynman dropped a piece of the same O-ring material into a glass of ice water and showed the whole committee exactly how it lost its flexibility. NASA redesigned the joint, and more importantly, rebuilt the rule that engineers could veto a launch. Number 2 took 17 years to actually change anything, because the exact same kind of debris strike had happened on almost every shuttle flight before it. A piece of foam insulation broke off Columbia's external tank during launch in 2003 and punched a hole in the wing's leading edge. Engineers on the ground asked for spy satellite imagery of the damage and were turned down because foam strikes had never caused a loss before. The shuttle disintegrated on re-entry over Texas, killing all 7 crew. NASA finally mandated on-orbit inspection and repair for damage nobody had bothered to check for before, and the fix effectively ended the shuttle program's future. Number 1 didn't just add a new rule. It created the discipline that writes all the other rules. The world's first jet airliner, the de Havilland Comet, started breaking apart in midair in 1954, and investigators pressurized a full fuselage in a water tank, cycle after cycle, until it failed to find out why. What they found was metal fatigue starting from a rivet hole at a square window's sharp corner, a crack invisible until it wasn't, and it became the founding case study of modern crash investigation. The redesigned Comet 4 that followed had oval windows. Every rounded window on every jet built since is still in part a quiet apology for what that square one did. None of these 7 disasters happened because the physics were mysterious. They happened because the physics were understood too late. And every rule this industry takes for granted now is really just a memorial with a part number.